that within the budget? Well, yeah, we drilled it within budget, but now we need to know how long it's going to produce. And this is the effect of doing something different. Here's a decline curve for a particular field that by, where this ends in 2009, about now that field should be at its economic limit, except we realized we could inject water back in the 80s. And this is today's profile up there. That's all the extra oil we're getting out by injecting seawater. And of course, all through that time, there's been a lot of volatility on the price. So you probably don't want to make your decisions when the price is way up here and think it's going to stay there. And if you make them down here and assume it's going to stay there, you're going to be wrong too, because as I said, nobody is very good at forecasting the price of oil and gas. And then you go into an old well, maybe there's something they didn't punch holes in. We tend to start at the bottom and work our way up because the pressure is higher down there. So once we have finished this zone, maybe we should come up here and take another look at that one. So a lot of geologists and engineers are studying wells that were drilled 20 years ago to see if there's anything left that they need to go back and revisit. And ultimately, what did we learn? Well, is there value to the data we just collected? Even in a dry hole, when you don't find anything, there's value. Because maybe the guy at the other leased block over there will pay for the data that you just got out of the ground. And maybe we want to drill other wells. And then ultimately the real value is what we're going to do differently next time. And if we made a big investment in some kind of technology and it doesn't cause us to do something different, we should not have made that decision, or at least we won't do it again. And how do we share in the learnings inside our company and with other companies that maybe are our partners? I'm going to let you read that for a minute, and then we're going to change into technology. But ultimately, this deals with the thing that I put up first about the oil was found first in somebody's mind.
But you can take this quote or this saying, apply it to any business. The interesting thing about all this, how do you manage risk and opportunity? How do you invest in options when there's only 5 or 10% likelihood chance of success? When you decide to relook at old wells, to activate new wells, apply it to any industry. And so I kind of think broadly about what Chip is saying and how you apply it to your own industry or to any industry you're interested in.
Okay, we continually need new ideas then. And what we're doing right now, this is sort of a snapshot of the way the oil industry is structured right now. We do use satellite images a lot where we can pick a little spot in the Zagros Mountains of Iran and zoom in on that. And we can start to assign colors to the image. All this blue color here, that's a particular rock type that has attracted somebody's attention. We can zoom in on an area still further. This is the coast of Brazil showing the gravity, because the gravity is not the same all over the world. And here you can see the coastline runs right down through here like that. So this is oceanic crust out here, and this is continental crust over here. And that's the first place we often start saying, is there even a basin full of sediments that we ought to be interested in? Because the blue places are low areas, and what we're doing is seeing through the sedimentary cover to where the basement rock is. And before we started doing this, my company made a serious mistake in either Sudan or Chad. We went into an area and made a big investment only to find there were no sediments there at all. So you don't want to do that. Seismic surveys, I've already mentioned before, you make a loud noise on shore with either dynamite or these trucks, which are essentially big thumper trucks that vibrate, or offshore with an air gun that pops a noise. Noise goes down through the water, through the sediment, comes to a rock layer that reflects, comes back, and gets recorded. Data looks like this. You'll see that again in a minute. And then we spend a lot of time with 3D visualization of what we cannot see under our feet. So these are rock layers under the surface of the Earth. We image them with seismic data in a cube like that. We can extract a single surface from that, and we can paint that with various attributes that might be meaningful as to what kind of a rock it is and where the porosity is, because that's what we really want to know, is where are the pore spaces in which the oil and gas are hiding. Here's a field that's been developed, a number of slant wells. This one I can tell is offshore because they start from a common footprint up here and then they radiate out. various directions. And this is how we image a rock layer here and a number of faults that cut it. So those are surfaces on which there's been some motion. We make a lot of subsurface models in 3D space. And here again, we're planning a well that's going to come down and then turn and go more or less horizontal through that. This is that field in the North Sea that I showed you, and it's a model showing where the porosity is. So red areas are the highest pore space, and blue areas have nothing of interest. And then sometimes we look very small and very close with microscopes and electron microscopes, and we're looking into the pore system to see why the rock behaves the way it does. And just as an example, over here, these are pores. Everything blue is epoxy that we injected into the rock. These are pores that are isolated from each other. That's got a big crystal growing in it. But these are non-touching pores. So it may be highly porous, but it's got no permeability because you can't push fluids through that. It's like a box of ping pong balls. There's a lot of pore space inside the ping pong ball, but it's not touching them. So you can't move from one ping pong ball center to another. So this rock has porosity of about 26%, but almost no permeability. And then sometimes we're just looking to see what's in the pores. What kind of crystal is it? Will it be water wet? Will it be oil wet? What kind of properties will it have? Creative well design. This is a single well in Venezuela. And what they're doing there is tapping a number of little isolated sand bodies. And they drill out until they run out of sand, and they back up, and they do what's called a sidetrack, and they do another one, and they back up, and they do another one. So one well, the reason they can do this is that this drills very fast. Each one of these little sidetracks is about 2 days of drilling. So it's very soft, unconsolidated rock, but I've never seen another well that looked quite like that. And then we do a lot of what's called geosteering, meaning we want to stay in that particular layer or in that particular direction. Underneath one of our platforms, if you could see, in the North Sea, it looks like that. So a big part of planning a well is avoiding all the other ones that are already there. And we still go out in the field, and we still go out in modern settings that are representative of the kinds of rocks we're dealing with. So I do get a chance to snorkel around in the Bahamas and get paid for it. Nice part.